Hello everyone, I am Pavitra, pursuing fourth semester in the Department of Computer Science and Engineering at Sri Venkateswara College of Engineering, Bangalore. In today's video, I'll be discussing about the subject discrete mathematics structures, and the topic is derangements. Now let's see the introduction to derangements. Derangements are a special type of permutation where no element appears in its original position. They are often referred to as subfactorials and are denoted by the symbol n factorial. Understanding derangements can provide insights into combinatorial problems and probability theory. Definition of derangements. A derangement of a set is a permutation in which all objects are displaced. Mathematically, the number of derangements of n objects is given by the formula factorial n. Derangements can be computed using recursive relations or explicit formulas. Some important points about derangements includes these are also called complete permutations and displacements. It is a problem of arrangements under restrictions. They are widely used in combinatorics, probability, and puzzle solving. Some of the real life examples are Secret Santa. Everyone must give a gift, but nobody can give a gift to themselves. Mismatched letters problems. Letters put into wrong envelopes. Seating arrangements. Guest must sit in its seats not assigned to them. Formula for derangements. The explicit formula for derangements is factorial n equals n factorial summation of minus 1 power k by k factorial for k equals 0 to n. This formula derives from the principle of inclusion and exclusion in combinatorics. The recursive relation is defined as factorial n equals n minus 1 factorial of n minus 1 plus factorial of n minus 2. Some examples of derangements which includes for n equals 3 the derangements are 2, 3, 1 and 3, 1, 2. For n equals 4 the derangements are 2, 1, 4, 3 and 3, 4, 1, 2. These examples illustrate how permutations can be rearranged while ensuring no element remains in its original position. Counting derangements. The number of derangements can be approximated using the formula factorial n approximately equals to n factorial by e. As n increases, the ratio of derangements to total permutations converges to 1 by e. This approximation allows for easier calculations for larger sets of elements. Some of the applications of derangements include problems involving wrong placement. Classic hat check problem. Suppose n guests at a party check their hats, but when they leave, each guest randomly receives a hat. A derangement counts the number of ways no guest gets their own hat. Lost keys problem. If n people randomly pick keys, how many ways are there so that no one picked their own key? Cryptography, Secret Santa. In secret gift exchanges, we want each participant to be assigned someone else, not themselves. Derangements ensure fairness and secrecy. Error detection and correction. In communication protocols, derangements are used when modeling permutations of data where no data item should return to its original position. For example, shuffle based encryption, combinatorial proofs and counting. Derangements help in proving inclusion exclusion principles, especially counting permutations with no fixed points, analyzing surjective mappings between sets where certain restrictions are applied, game theory puzzles. Derangements are used in designing puzzles like deranged chessboards or incorrectly placed pieces puzzles, ensuring no piece remains in its starting point spot. Properties of derangements. Derangements are a subset of permutation and share many properties with them. The number of derangements is always an integer and it can be odd or even depending on n. The properties of derangements make them interesting to study in combinatorial context. Inclusion and exclusion principle. The derivation of derangements fundamentally relies on counting permutations with zero fixed points using inclusion and exclusion. We subtract permutations with one fixed point, add those with two fixed points, and so on. Generalization. Derangements can be extended to partial derangements where only a subset needs to be displaced. Also connects with Rencontres numbers and counting permutations with exactly k fixed points. Visualizing derangements. Visualizations can help in understanding the concept of derangements. Diagrams such as permutation graph can illustrate which elements are displaced. Visualization techniques aid in teaching and learning about derangements concept effectively. Challenges in derangement problems. Derangement problems can become complex as the number of elements increases. Recursive and combinatorial approaches can become computationally intensive. Many students find derangements challenging, highlighting the need of clear explanations and practice. Some of the derivation ideas are: start with all the n factorial permutations, subtract the number of permutations where at least one item remains fixed, use the principle of inclusion exclusion to correctly count arrangements. Some fun puzzles involving derangements that are how many ways can four people leave a dinner and pick up the wrong code? How many wrong mailings if five letters are sent incorrectly? Conclusion on derangements. Derangements play a crucial role in discrete mathematics and combinatorics. They offer a fascinating look at permutations where none of the elements remain fixed. Further exploration of derangements can lead to deeper insights into mathematical principles and their applications.